Welcome back everyone to another video in our pipe stress analysis course. In this video, we are going to learn how to model a steel structure into our piping system. Sometimes in our piping system, we provide a support that it is rested on a steel frame. In this case, it will not be an accurate assumption to represent our support in Caesar 2 software as a rigid support, because actually this I-beam section has a specific stiffness, and as we apply load on it, due to the piping own weight or due to the expansion or whatever, this beam will start to deflect based on the stiffness of the selected I-beam. This deflection of course will affect the flexibility of our piping system. Of course it will add a certain flexibility to our piping system because it is not fully rigid 100% that prevents any kind of movement. That's why it will not be an accurate assumption to model it as fully rigid support, and it is better to model our steel structure into our Caesar 2 piping input piping model in order to let Caesar 2 calculate this deflection of the steel beam and add this flexibility to our piping system. So how can we create this steel structure model? This is what we are going to learn in this video. Caesar 2 software has a very handy tool to model any steel structure. We will start by inserting a new file. However, here instead of selecting piping input, we will select structure input. We will give it any name. Let's call it try, for example, and you will select where do you want to save it. Let's select desktop and this folder, structure input. Let's select this desktop and this folder called structure input, and you press OK. It will open for you this tab here. It is going through some steps before starting your modeling. First step is going to select your units. It is going to confirm for you that you are going to use the same units that you have selected as the default units of Caesar 2, and press next. Here it is going to ask about the vertical axis. You can select either Y or Z to be your vertical axis, but we are going to integrate this structure input model with our piping model, so it is better to keep both the same. So we will keep going with Y as vertical axis. Now it is going to ask you about your material specification. Here you can see this is the specification for a steel. Actually this is the yield strength 248 Newton per millimeter square, density, Young's modulus, shear modulus, Poisson ratio, all of that. This is for a steel. You can either keep these values or you can insert the accurate values of your steel member. Of course, you can find it in your specification. What is the grade of the steel you are going to use, or based on your structure engineer selection, and you are going to insert these values here. Press next. Now it is going to ask you about the cross-section selection. Which cross-section are you using? Here Caesar 2 has a wide library. We are going to select I-beam, for example W40 215, whatever the section you are selecting in your model, or whatever the structure engineer actually has selected. Press next. Yeah, and here let's go back. You can of course add another section if you have different sections in your model, but right now we are going to insert just a simple frame, so it is only one section. Here it is going to ask you, you have two methods actually to model your structure input in Caesar 2. Method 1 is in case if you have a simple system, just a frame or something, it is going to be similar to the piping input method which you are used to in Caesar 2. You are going to create nodes, and from each node to the other one you are going to connect with a certain structure element. In method 2, this is going to be useful if you have a complicated system or consisting of multiple nodes, because you are going to create just like a grid of nodes and you will start connecting between these nodes. But right now we are going with method 1, and you will press finish. It will open for you this structural input window. you can see here the unit which you have already selected as default. This is the vertical, you selected y-axis as vertical, and this is the material ID, you selected material ID, it was named 1, and this is the specification for it, and the section ID which you have already also selected. We will start modeling our frame by selecting this option, E dimension, and here you are going to open it. It will ask you from to. This is similar to the piping input, so we are going to select from 1000. It is very important here to select nodes that is different from our piping input, because we want to integrate between both of them after we finish our structure input here, and it will not be possible if we are using the same nodes numbering here and in the piping input also. That's why I'm going to use 1000 increment here. So I will start from 1000 to 2000, and this is the dimension. I'm going vertical now with the column with dimension of, let's say, 4000, and this is the column which we have here between 1000 and 2000. Section ID is going to be 1, and the material ID is going to be 1, which we have already earlier defined. Close this one and press it again to insert the other element. We will open here, we will connect between node 2000 to 3000, and it is in Z direction. Let's say 3000 millimeter. Let's keep it in the other direction, minus 3000, and this is the element, and again the material ID and the section ID are 1. We have only one. Insert another one from 3000 to 4000 with dimension of another 3000, because I want to connect our pipe to this node here in the middle of this beam. That's why I created a node in the middle. And the section ID is 1, and the material ID is 1 also. Our last element is between 4000 and 5000, and the height of it, let's revise what was the height here. It was 4 meters, so in the y direction minus 4 meters. Now we have our frame here. First we want to anchor this point here and this point here, so we are going to select this fix, and we will open it, and it will ask us from which point to which point and by which increment. This point here is 1000, and this point here is 5000, and we want to anchor both of these points. That's why we are going to select from 1000 to 5000, and with increment of 4000, and here it is going to be fixed. It fixed for you point 1000 and 5000. This is useful if you have multiple column, like I said earlier, and for example these nodes were 1000, 2000, 3000, 4000, like this. You are going to select the first node and the last node, and the increment is going to be 1000, for example. But here I had only 1000 and 5000, so the increment was 4000 with the start and the end nodes. Let's say, for example, that you want to rotate any of these structure elements. You are going to select this option here, orientation, orient, and you will select, for example, from 2000 to 3000, and with angle of 90 degree, and you can see that this element here, it was rotated by 90 degree. But let's cancel that because we want to keep it like this. So now we have finished modeling our steel structure In our next video, we will learn how to integrate between both our structure input model and our piping input model. Thank you.